All right, so I believe I'm recording. Let's take a look at this problem. They give us two functions f and g, and they ask us to determine if these two functions are inverses of each other, and to make that determination by finding the function composition f composed with g and comparing it against the function composition g composed with f. If they're both equal to x, then I know that these functions are inverses of each other. If they're not equal to x, then I know they're not. So let's find f composed with g. So here, this is the notation that's saying that the input of f is going to be this function g of x. So g of x is this cubic expression, this 32 x cubed minus 6. And f is the function that always creates a fraction. The denominator is always 4, and the numerator is always the cube root of 2 times whatever the input is, and then add 6. This time the input is 32 x cubed minus 6. So we want to see if we can simplify this. Let's distribute the 2 to both of these terms. So I have the cube root of 64x to the third power minus 6, all divided by 4. And I don't believe that I can truly simplify that. Even though I could factor a 2 out, I can't find a common factor to both of these terms. It's a perfect cube, but I could simplify that radical at all. So I'm going to conclude right now that these are not inverses of each other. But it's possible that somebody started out with g composed with f. So let's find it, and let's illustrate that it's also not equal to x, and that there's no way that these two functions could be inverses of each other. So what does g do to the input? Well, g always creates a subtraction problem where the first term is 32 times the input raised to the third power. And this time that input is this fraction. So this means that this fraction times itself 3 times, 3 factors. What do we get? Well, since this is the cube root of 3 and you're cubing it, the numerator becomes just 2x plus 6. And this denominator, 4 cubed, is 64. So 32 divided by 64 is 1/2. And what do we get here? Well, both of these get divided by 2, so we have x plus 3 minus 6. This is x minus 3. That is not equal to x, so I would immediately conclude that these are not inverses. So whether you found g composed with f or f composed with g, either one, as soon as you recognize that it's not equal to x, you know that these are not inverses, that these functions are not inverses of each other. I'm not saying that the inverses don't exist. Maybe it does, but f and g themselves are not inverses of each other. So I hope that helps, and I'll talk to you later.